the graph of the quadratic function f of x is equal to x minus 1 squared minus 9 by identifying the following items: the vertex, Y-intercept, X intercepts, and the opening of the parabola. And then once we have the graph, we'll state the domain and range as well as the axis of symmetry. So we have the function f of x is equal to quantity x minus 1 squared minus 9. This function is in standard form. Standard form is f of x is equal to a times x minus h squared plus k. And in this case, the vertex is the hk, or in our problem, it is opposite of what we have inside the function. So it's 1 and exactly what we have outside the function, negative 9. Or the parabola has been shifted 1 unit to the right, 9 units down. So we'll start by graphing the vertex. So we have negative 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 1, negative 9 for the vertex of the parabola. Looking at the function we were given, f of x is equal to x minus 1 squared minus 9. The leading coefficient is positive. That is, this value of a is greater than 0. Since the value of a is greater than 0, the parabola will open upwards. Opens upwards. Next thing we want to look at is the Y-intercept. For the Y-intercept, this is when x is equal to 0. So I'm going to plug in 0 into the function and find the corresponding y value. So we have f of 0 is equal to 0 minus 1 squared minus 9. Inside the parentheses, I have a negative 1 squared minus 9. Negative 1 squared is a positive 1 minus 9, which gives us a negative 8. The y-intercept is the point 0, negative 8. So here is 0, negative 8. The next thing we want to find are the x-intercepts. The x-intercepts are when y is equal to 0. If we would take our function and set it equal to 0 and solve for x, that would be our x-intercepts. So we have x minus 1 squared minus 9 is equal to 0, and we want to solve this for x. We do so by adding 9 to both sides of the equation, and we have x minus 1 squared is equal to 9. To solve for x, I'm going to use the square root property here. I'm going to square root both sides of this equation, which will undo this operation of the square. And so we have x minus 1 is equal to plus or minus, since I've introduced the square root, plus or minus 3. I'll make two little equations. I have x minus 1 is equal to 3, and I have x minus 1 is equal to negative 3. Solving each for x by adding 1, I find that x is equal to 4 for the first one, and x is equal to negative 2 for the second one. This tells us that our x-intercepts are as follows. The x-intercepts are the points 4, 0, and negative 2, 0. The x-intercept is when y is 0. And they are the ordered pairs 4, 0, and -2, 0. So plot these points. Here we have -2, 0. And here we have 4, 0. So we've identified the vertex, and the vertex was 1, -9. We identified the y-intercept. The y-intercept, the point 0, -8. We identified the x-intercepts. In this case, we had 2 x-intercepts. The x-intercepts were the points -2, 0, and 4, 0. We identified that the parabola opens up because the leading coefficient is positive. And so graphing the parabola, we start down here at our vertex. It goes through this y-intercept here, or through this x-intercept here. It goes through the y-intercept and the x-intercept. So that is the graph of f of x is equal to x minus 1 squared minus 9. I'd also like to state the domain and range. So the domain of a quadratic is going to be all real numbers. And so that's -infinity to positive infinity using interval notation. The range, looking at the graph, we have a low value or a minimum, and the smallest y value corresponds to the second coordinate or y value of the vertex, which was -9. So the range is -9 to infinity. Now, the vertical line that goes through the vertex, and that's at x is equal to 1, the vertical line that goes through the vertex is what we call the axis of symmetry. And it's symmetric with respect to this vertical line. What's on the right-hand side is the same as what's on the left-hand side. And so to describe a vertical line, I'm going to use the variable x, and we have x is equal to 1. So the axis of symmetry is x is equal to 1. The domain was all real numbers, -infinity to positive infinity. The range was -9 to infinity. So we have sketched the graph of f of x is equal to x minus 1 squared minus 9, as well as identified some key elements of the graph.